Okay, so here, starting with the limiting reactant, we figured out in the previous two options of problems that the aluminum was the excess and the chlorine was the limiting. We had already figured that out because we worked both of those problems. We did the 100 grams of aluminum and the 100 grams of chlorine. We worked them to the aluminum chloride product. The one that came out smaller for the product was the chlorine, so the chlorine was the limiting reactant. That means we know that aluminum's excess, this one's excess, this one was the limiting reactant, based off of the numbers. Sorry, what? Two? Huh? Well, they're supposed to be put right in. That's interesting. It's not balanced without the two. So yes, noticing on the notes that the 2 is missing here, so you might need to put that in there. Alrighty. Now, moving along. This one we did and completed, but I'm just going to run through the steps again, showing you how you would set this up. You start with your limiting reactant, the amount that you start with, like 100 grams of the chlorine is how much you start with of the limiting reactant. Now we're going to work it, stoichiometry. We're going to work the chlorine to the aluminum. As we do so, we change it to moles of chlorine, then moles of aluminum, then grams of aluminum. Set up the T-chart, set up your canceling. Now we're going to insert the conversion factors. 70.90, remember, is the molar mass of chlorine. We've already calculated that in the previous problem. And the mole ratio is 2 to 3. The 1 mole of aluminum to 26.98 grams of aluminum off the periodic table also found. What you're going to do when you cancel and multiply, you end up with 25.4 grams of aluminum. Now, what does that number actually mean? This is the amount that was used in the reaction. All the rest of it is leftover or didn't react and remains in the flask or the reaction vessel or the reaction container, whatever you want to call it. That's what's used in the reaction. So now you take the starting amount. Starting amount of aluminum was 100 grams. So this is the starting amount. And we're subtracting the used amount. Okay? And that gives us our leftovers, or what remains of the aluminum. Now that's kind of a waste of aluminum if you ask me. And I guess this was a typo, because that really should be a 6. But looking here, technically I guess too, if we subtracted correctly, because this is one's place value, this really should end up being just 75 grams. Technically, we're going by significant figure subtraction rules. However, that's just a little added extra. That means, though, when they decided to react these things, they pretty much wasted 75 grams of aluminum. So sometimes it's better to calculate so you're getting it closer so you're not wasting as much. But this is the leftover. That's what remains in the reaction vessel. This is one way to do it. Limiting to excess and then do your subtraction. Now, I really like this way, and I use it pretty often. However, I've also developed an appreciation for the second method here, which is subtracting products before you begin, and then you work the product to the excess. So, and this is kind of how that mole, if you do option 1 with the moles, that's how it makes it a little bit shorter. So if you go back to option 1, option 1, we had the aluminum chloride. Okay, the aluminum chloride produced from the aluminum, that was 3.71 moles, right? If you look back at option 1, when we did the T-chart, we got 3.71 moles for the aluminum chloride produced. Now, for the second T-chart, the AlCl3 produced from the chlorine. This one was 0.940 moles. You go back and check, but those were the two products that we got in option 1. Now you can also use this for option 2 if you're doing the grams, but I'm using the moles because it takes less steps. So go ahead and subtract that. You do 3.71 minus 0.94, and we're going to end up with 2.77 moles of AlCl3. So you can subtract the product. Then this is what starts your T-chart. You take this one and you work it over here to the grams of the aluminum. So I start with my 2.77 moles AlCl3. I'm going to go to moles of the aluminum. Then I'm going to go to grams of the aluminum. Setting it up this way, this makes my excess problem a little bit shorter. So if you did option 1, this one works well with option 1. So let's go ahead and diagonal down these things, get them set up. Moles AlCl3 and moles Al. This is the mole ratio step, is what we want. So 2 to 2, multiple. Then here at the end we need to do grams, so 1 mole of aluminum was 26.98. 2.77 times to 26.98, really the 2's cancel. This ends up giving us 74.7 grams of aluminum, which is very close to the 74.6 that we got in the previous option that rounded to 75. Either way, those answers would be accepted. Now some people might like the product way where you subtract product first, then do the T-chart. Or you might like to do the limiting to excess way, which is the one in the previous slide. Either way, they both work. So you can see it again, where do the subtraction first. So this way you subtract the products first, then you start your T-chart, like so. Moles of the product working to the moles of the excess reactant. Put in the mole ratio, and we end up here getting the remainder. Like I said, some instances this way actually works better. Some instances the limiting to excess way works better. Really depends on the way the problem is set up. And it also kind of is about how you think about it. If you like to do starting minus used, gives you the extra. Or you can subtract the product, get your extra first, and then work it to the excess reactant.